2-dimension, it will have two components. 1-dimension, only one component. 2-dimension, velocity, displacement, velocity, acceleration, force, everything will have two components. Every quantity will have two components, especially vector quantities. Okay. Instantaneous velocity, how can you define in two-dimensional motion? Definition, you see, instantaneous velocity means velocity at a particular instant. So it is given by the limiting value of average velocity as the time interval approaches zero. This we have defined in one-dimensional motion also in the same way. No change. Limit delta t tends to zero, delta r by delta t. Then we use the displacement. That is equal to dr by dt. This is displacement, this is time interval. Displacement by time, that is the time interval, displacement by time interval. So that is the average velocity. And what is the limit given? Time interval tends to zero. And time interval tends to zero. What is the average velocity? That is instantaneous velocity. So equation is this. Equation for instantaneous velocity, limit delta t tends to zero, delta r by delta t. We put vector symbol here, vector. So in 2-dimension we express vector symbol. 1-dimension also it is a vector, but we are dealing with only in one direction. So we haven't used the vector symbol in 1-dimensional motion. We know velocity is a vector quantity. So actually in 1-dimension also it would have been represented, but we are not representing because that is 1-dimension, not changing the direction, one direction only. But here we are discussing the motion in a plane, xy plane. Body is moving in xy plane. So we have to use the vector symbol. It can move either upward, downward, like that, sideways, like that it can move. But in 1-dimension only along the straight path. Motion we have discussed straight path only, no movement, upward, downward, like that, no movement. That was a straight line motion. But here we are discussing the motion in a plane. In a plane means, suppose this is a board, this is a screen. So this movement you see, cursor movement, this is a 2-dimensional motion. In this plane, the movement of this cursor, that is the motion in a plane. So like that, any direction in this plane it can move. So here the definition, we have to use the vector symbol. Well, instantaneous velocity vector v equal to limit delta t tends to zero, delta r by delta t. Displacement also is a vector quantity equal to dr by dt. Here you have to put the vector sign. And what is the direction of velocity? As it is a vector quantity, we should know what is the direction. Direction is given by the displacement, because velocity is displacement by time. So what is the direction of velocity? Direction of velocity is direction of displacement. So direction of velocity at any instant on the path of an object is tangential to the path at that point and is in the direction of motion. That I will share another page to show that. This one. You see, here, the body, this is xy plane. So this is x-axis, this is y-axis, and this is the origin. And body's motion is shown by the red line. Body is moving in this plane. A body is moving in this plane along this path. Arrow mark is shown in the direction of motion of the body. And suppose at this particular point, this one, I am taking this point. What is the direction of velocity? What will you do? In order to know, we know body is moving in this direction. So at a particular point, how will you find the direction of velocity? You have to draw a tangent at that point in the direction of motion. You see, I have drawn a tangent in this direction. This is the tangent drawn to this curve. At this point, I want to find the velocity, direction of velocity at this point. So what should I do? Draw a tangent. How to draw the tangent? In the direction of motion. See, upward. I am not drawing the tangent downwards. Why? Because motion is upwards, like this body is moving. So you have to draw the tangent in that direction. Understand? Suppose I want to know the velocity at this instant. Direction of velocity. Magnitude we know. Magnitude is equal to root of vx square plus vy square, that we have to do. That I will tell you after this. So direction, in order to find the direction of velocity at a particular instant, what will you do? Draw a tangent at that point in the direction of motion of the body. This is the direction of motion. So suppose I want to find the direction of velocity at this point. What should I do? Draw a tangent like this. Draw a tangent in the direction of motion of the body. Then find the slope. Slope. That means tan theta. Tan theta, find out. That will give that direction. Tan theta. Draw a tangent at that point and find tan theta. That means that will give the direction. With the x-axis, how much it is inclined. This is the horizontal direction. This path is the horizontal direction. With the horizontal line, how much that V is inclined. That will give the direction. So angle is giving the direction. Angle theta gives the direction of motion of the body. So we find tan theta. If you are asked to find the direction of velocity, what you have to find out? Tan theta. Tan theta is equal to slope of that line. Slope of the line, Vy by Vx. So tan theta will give the slope of that line, and that is the direction of velocity at that particular instant of time. So tan theta equal to Vy by Vx, and theta equal to tan inverse Vy by Vx. And for that, ask you to find this angle. I ask you to buy Clark's table. And I'll see if whether all of you got Clark's table, and only I can discuss. I will give some more days to buy that, because some areas are containment, so you cannot go outside like that. Some problem is there. So that so I will give you one more week. Then if possible, you buy, and when you get, all of you get, I will discuss how to find this angle and all. Okay. So here Vx, Vy and theta are shown in figure. Vx, this is x component of velocity. This is velocity, and this is x component of velocity. This is y component of velocity. We are splitting this vector into two components, x component, y component, and Vy by Vx, slope of that line. Slope of that line gives the inclination. That means the angle or the direction of velocity at that particular instant. So if you are asked to find the direction, what will you do? Draw a tangent and find tan theta. That will give the direction of velocity at that particular point. Okay. So we can go to the last page. So direction of velocity at any point on the path of an object is tangential to the path. So you are drawing the tangent. Tangential to the path at that point and is in the direction of motion. So this part is important. Direction of velocity. How to find direction of velocity? Draw a tangent and find that angle theta. So direction of velocity at any point of the object is tangential to the path at that point and is in the direction of motion. Or you can draw a tangent. Tangent will give the direction of motion. Tangent to the path in the direction of motion will give the direction of motion of the body. So this definition is important, and we have to do problems with that. You can see we can express V in component form. So whenever you tell about velocity in 2 dimensions, it will have 2 components. Whenever you tell about displacement, it will have 2 components, x component and y component. So all vector quantities, velocity, acceleration, all have 2 components in 2-dimensional motion. So now we are going to express velocity in component form. So we have got the equation now, v equal to vector v equal to dr by dt. First derivative of position vector. First d by dt means first derivative. First derivative of position vector is velocity. This is the formula. Vector v is equal to dr by dt. Limit delta t tends to 0, delta x by delta t. So we are splitting this into two components. So limit delta t tends to 0 is taken outside. It is common to both these terms. And delta x is the x component. For change in position along the x direction. That I have explained. I don't know whether I have revised that for. I will show you that delta x by delta t. So x dash minus x into I cap plus y dash minus y into j cap. This is we have taken delta x I cap plus delta y j cap. So displacement has two components, delta x into I cap plus delta y into j cap. So velocity we have taken, the average velocity has two components, delta r by delta t. Vector v equal to vector delta r by delta t. Delta r we have written delta x I cap plus delta y j cap by whole divided by delta t. Then we have delta t is given to both the terms, delta x by delta t I cap plus delta y by delta t j cap. So we got vector v bar. Bar is there to show that it is average velocity. Vx bar I cap plus Vy bar j cap. Vector v bar is equal to delta r by delta t. The direction of the average velocity is same as the displacement. So this is what we have discussed in the last class. Average velocity has two components, Vx bar and Vy bar. Similarly, this instantaneous velocity is also having two components. See, the limit delta t tends to 0, delta x by delta t. Splitting into two terms, x component and y component. Delta x by delta t I cap. This is the average velocity. When limit is given, time interval delta t tends to 0, average velocity gives instantaneous velocity. That is our definition. So we are giving delta t tends to 0, limit delta t tends to 0, and we are splitting into two terms. Mute your mic, please. Delta x by delta t into I cap plus delta y by delta t into j cap, split into two terms. Then you give this limit to both the terms. Limit delta t tends to 0, delta x by delta t into I cap plus this limit you give to the other term also. Limit delta t tends to 0, delta y by delta t.
Teacher,
Yes.
Divan ചെന്നറിയോ?
Divansha, 38 all. Okay. So here we have given the limit to both the terms, and then we know this is what limit delta t tends to 0, delta x by delta t. What is it? Dx by dt into I cap plus dy by dt into j cap. What is dx by dt? That is velocity, is x component. Vx into I cap plus Vy into j cap. So we got the two components of velocity vector. So what is the difference in instantaneous velocity equation and that average velocity equation? We put a bar there. Vector v bar is equal to Vx bar I cap plus Vy bar j cap. That is the difference. Here we are not putting the bar. When we put a bar here, that becomes average. When it becomes average, we will not write dx by dt. That is delta x by delta t only we write. Instantaneous, we write dx by dt. Then average, we just write delta x by delta t only. When time limit, we will not give to average velocity. Time limit is given to instantaneous velocity. Then it becomes dx by dt I cap, dy by dt j cap, like that. So you should know the difference while writing. So children, better write and study all these derivations. Otherwise, you may feel difficulty. So vector v is equal to instantaneous velocity. How will you read this? This is instantaneous velocity vector v equal to Vx I cap, x component of velocity, Vx I cap plus Vy j cap, where Vx equal to dx by dt, and that you have to write here. But how you got this step? How you got this step? This is we have taken dx by dt is Ex. That is written here. Vx equal to dx by dt. And here we have written this term is equal to Vy. So that you have to write here. Vy equal to dy by dt. And how will you find magnitude of velocity? Root of Vx square plus Vy square. Very important. While splitting a vector ax a into two components, we have written in component form root of x square plus ay square, like that. Vector v, magnitude of vector v, that means v equal to, magnitude of vector v is equal to root of vx square plus vy square, root of vx square plus vy square. And direction is tan theta equal to this one. Magnitude is root of vx square plus vy square, and direction is given by tan theta equal to vy by vx, or theta equal to tan inverse vy by vx. Tan inverse value, I told you now, some more time I will give you to buy the Clark's table, and after that only we can discuss how to find this inverse value. Okay, that I will explain how to find, while doing problems I will explain how to find this theta value. So now we have defined instantaneous velocity. Next is acceleration, average acceleration and instantaneous acceleration in component form we are going to discuss. Okay, the average acceleration, and we put a bar for average. So acceleration is a vector quantity, vector A bar of an object for a time interval delta t. Will you put a vector for delta t? No, time is not a vector quantity. Moving in xy plane. So average acceleration, vector A bar of an object for a time interval delta t moving in xy plane is the change in velocity divided by time interval. So acceleration is change in velocity by time interval. Acceleration is change in velocity delta v by delta t. This is the average acceleration. You see, average acceleration we are not giving the time limit. Instantaneous acceleration we give the time limit to this average acceleration. When time limit is given, that means delta t tends to 0, delta v by delta t will give instantaneous acceleration. So if we simply write delta v by delta t, that is average acceleration, velocity change by time interval. So we are splitting into two components, average acceleration also we are splitting into two components. So delta v is split into two components, vx I cap plus vy j cap, and delta vxi by delta t plus giving the delta by delta t to both the terms, delta vy by delta t into j cap. And we know delta vx by delta t, change in velocity along the x direction divided by the time interval, that is average acceleration along the x direction, average acceleration ax bar I cap plus ay bar j cap, where ax equal to delta vx by delta t and ay equal to delta vy by delta t, average. So I think you understood how to write the expression for average acceleration. Average acceleration is equal to, in component form, ax I cap plus ay j cap, where ax, what is ax here? What is ax here? Ax equal to delta vx by delta t. What is ay? Delta v by delta t. That you have to write bracket. Then next is instantaneous acceleration. Can you tell how will you write instantaneous acceleration? What change you should do in this equation? Vector, we will not put this bar symbol. we simply write vector A is equal to, then what change we will give to this expression? Limit. We have to give the time limit. Time interval, the limit delta t tends to 0, delta v by delta t, that will be instantaneous acceleration. So let us see then how to write this. And in the component form, what will be the answer? Vector A equal to ax I cap plus ay j cap, but ax equal to dvx by dt and ay equal to dv by dt. For average, we use delta. For instantaneous, we use dvx by dt, dv by dt. That is the difference. You should understand the difference. See how it is written. As the time interval tends to 0, average acceleration becomes instantaneous acceleration. So this is the equation. Vector A is equal to limit delta t tends to 0, delta v by delta t. Then what is delta v in component form? Delta vx I cap plus delta vy j cap. Then we are splitting into two terms. Limit delta t tends to 0, delta vx I cap plus delta t plus delta vy by delta t into j cap. So we just substituted vector v in component form. What is the vector v in component form? Delta vx I cap plus delta vy j cap. And we split into two terms and give the limit. So for what we are giving the limit? In order to find instantaneous acceleration. So limit delta t tends to 0. Give this limit to both the terms. Delta vx by delta t into I cap plus limit delta t tends to 0. Delta v by delta t into j cap. Then you know, when we give limit to the average velocity, when we give limit to the average acceleration, this is delta v by delta t is average acceleration. When we give this time limit, the time limit delta t tends to 0, average acceleration, velocity by time, that is acceleration, delta vx by delta t, that is average acceleration. So when we give the time limit delta t tends to 0, delta vx by delta t, what it becomes? That becomes the instantaneous acceleration dvx by dt. Ax is equal to dvx by dt and ay is equal to dvy by dt. Limit delta t tends to 0, delta vx by delta t, that is dvx by dt. Limit delta t tends to 0, delta vy by delta t, what is it? That is ay into j cap, ax into I cap plus ay into j cap. So that is the component form of acceleration vector. Vector A, instantaneous acceleration, vector A equal to ax I cap plus ay j cap. What is the average acceleration? We put a bar here and we write ax I cap plus ay j cap. But what is ax? It is not dvx by dt. It is delta vx by dt. It is here ay. What is ay? dvy by dt. What is dvy by dt? Ay. But in average, what will you write? Delta vy by dt. Not giving the time limit in average acceleration. So that becomes ay bar there. Here it is ay. There it is ay bar and ax bar. But that is delta vx by delta t, delta vy by delta t. So I think you understood the difference between instantaneous acceleration and the average acceleration. Let me ask question whether you understood that. I should check now. Change in this expression. So what is instantaneous acceleration? And then I'll ask to Adityan. Can you hear? Expression tell average acceleration. Average acceleration. Adityan is not hearing. Midun, are you there? Midun. No answer. Abhinav. 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 Simple question. Instantaneous acceleration is this. What is average acceleration equation? That is the question. Girls not. Okay. Lakshmi Priya. Lakshmi Priya. Lakshmi Priya, are you there? Lakshmi Priya. All of you are there, I know, but no one is answering. Aditya Sindhu. Aditya Sindhu. I am simply wasting time. No one is answering. Who will answer my question then? Krishna Sri is there. Krishna Sri. Krishna Sri. Krishna Sri. I know.
Yes, teacher.
Okay. See, this is equation for instantaneous acceleration. Okay? In component form. Vector A equal to ax I k plus ay j k. What is the equation for average acceleration? I check whether you understood the difference. Average acceleration, how will you write? Same? Any change? Why not answering? Don't know? Not answering. Krishna Prabha is there? Krishna Prabha?
Yes, ma'am.
Please tell the difference. This is instantaneous acceleration. What is the expression change in the average acceleration?
That a vector a bar
Equal
is
to.
equal to ax I cap plus ay j cap.
Where ax equal to what? What is ax then? Will it be same as this?
X.
Will it be? This is dvx by dt. Is it same for this average also?
No.
Then what it will be?
Delta.
Yes. Delta.
Vx by delta t.
Delta t. Correct. Delta vx by delta t. What will be ay?
Ay delta v by delta t.
Delta t. Understood. That is the difference. Okay. So here it is instantaneous. So we give the time limit. Limit delta t tends to 0. Delta vx by delta t into I cap plus limit delta t tends to 0. Delta v by delta t. Actually, this is the average accelerations x component, average accelerations y component, and when we give the time limit, we give an instantaneous accelerations x component, instantaneous accelerations y component. So ax in that case it is equal to delta vx by delta t, and ay is delta vy by delta t. But instantaneous, what is ax? Ax is dvx by dt. And what is ay? dvy by dt. That is the difference. So you have to write this. Just by after writing this, you have to write in what is ax. You have to write here dvx by dt. What is ay? dvy by dt. But in average, what will you do? I will show that. This is all. Hello. Here ax equal to delta vx by delta t. Here y equal to delta vy by delta t. Actually, that you have to write in bracket here. I didn't write. You can write. And that is the difference. Here it is delta vx by delta t for ax. And here it is delta v by delta t for a y. But there, instantaneous, that is dvx by dt. dvx by dt. dvx by dt. Ax equal to dvx by dt. Ay equal to dv by dt. dvy by dt. Suffix, you have to write as suffix y component of velocity, x component of velocity, v, x suffix x. v, y component of velocity. അതിൻ്റെ ഫസ്റ്റ് ഡെറിവേറ്റീവ് d by dt, ഫസ്റ്റ് ഡെറിവേറ്റീവ് ഓഫ് വെലോസിറ്റി y component, ഫസ്റ്റ് ഡെറിവേറ്റീവ് ഓഫ് velocity x component, that is the x component of acceleration. Okay. In some important note is given. In one dimension, velocity and the acceleration of an object are always along the same straight line. So in one dimension we have studied velocity's direction and acceleration direction will be same. Why? Suppose body is moving along the x-axis. What is the velocity's direction? Along the x-axis. What is the acceleration direction? Along the x-axis. Both are in the same direction, not at all changing any direction. So in one dimension, the velocity and the acceleration of object are always along the same straight line. Another example, body is moving along the y-axis. One dimension motion. Body is moving along the y-axis. What is the direction of motion? Along the y-axis. What is the direction of velocity? Along the y-axis. What is the direction of acceleration? Along the y-axis. All are along the same axis. So in one dimension, velocity, displacement, velocity and acceleration all are along the same straight line, in the same direction. Sometimes it may be, some body may be moving upwards, body may be moving downwards. Same direction is not changing. Okay. However, for motion in 2 or 3 dimension, velocity and acceleration vectors may have any angle between 0 and 180 degree between them. See, one dimension, displacement, velocity, acceleration, all are in the same direction. But in 2 or 3 dimension, they can have any value between 0 and 180 degree. For that, a textbook one figure is given. I will